Morning class, now we proceed next section regarding how to use integration to find the volume of the region revolved at the x-axis or the y-axis. So now you can try to open up your books, look at page 107. Before 107 is about theory, how to obtain the formula. So this one I'm not going to share with you. So we'll focus on how to use this formula. So look at page 107. So the formula will be like this. Find the volume generated when the region bounded by the curve. So at first you need to identify where is the region that they mentioned. Okay, when the region bounded by the curve. So curve is this one. Bounded by x equals to A, x equals to B, and also x-axis is revolved 360 degree about x-axis, meaning that this shaded region, okay, every time before you find volume, you must have one shaded region, and then that shaded region will rotate 360 degree or any degree like 270 degree or 180 degree, but usually question will ask you 360 degree about x-axis or about y-axis. So I will talk about I'll discuss the formula first. How we find volume generated by this shaded region. Okay, formula is like this. Volume equals to integrate. If they say rotate with x-axis, here will be dx. And then in front of, always put a pi there. Integrate dx from where to where? The region is from A to B, right? So here you put A, here you put B. If here is x, then you substitute y square here. So I want to give you one simple example regarding how to get the volume formula. So I'll show you by using this simple example. So now I have a straight line. The straight line formula is this. I simply give you one formula. This is 3. So the equation of this straight line is y equals to 3. Then the question is like this. Find the volume generated by a region enclosed by y equals to 3. So you need to identify where is the region first. Enclosed by y equals to 3. So y equals to 3. Enclosed by y-axis. And then x equals to 4. So x equals to 4, and also x-axis. When this region rotate 360 degree about x-axis. So what shape actually you can obtain when this shaded region rotate 360 degree about x-axis? So can you imagine actually you can obtain a cylinder like this? If you cannot imagine, you try to cut out one cardboard and then you rotate and you try to imagine. When this green color cardboard rotate 360 degree about x-axis, you will obtain a cylinder like this. So if you use back the basic formula for volume for cylinder will be pi r square h. So according to this question, if I use basic formula, I will obtain pi radius is, from here radius is 3. So pi 3 square, the height for cylinder is this, right? Which is x equals to 4. So 4. When you simplify, you will have 36 pi. So volume for this cylinder. If I use volume, if I find volume by using the integration, I will have pi, always have pi in front, and then rotate with x-axis. So I have dx here, and then integrate from where to where for the x? Integrate from 0 to 4. And then here is x, meaning that here I need to substitute y square. If here is y, then I need to substitute x square. So memorize it. So y square, meaning that 3 square. So 3 square is 9. So I just integrate like usual. Integrate 9, I have 9x from 0 to 4. So I just simplify, substitute like usual. 9 times 4 minus 9 times 0. So simplify. You see, I also can get 36 pi. So this is what happened behind. So in your exam, in this topic, actually not only involve the simple volume like cylinder, cone, and so on, Sometimes you might obtain the shape like this, something like what we call the loudspeaker, the shape something like loudspeaker. And then you try to imagine if you have this shape, this shaded region, if rotate 360 about 360 degree about y-axis, you will obtain a cylinder, correct or not? And then if this shape rotate 360 degree about y-axis, you will obtain a sphere. And then this shape, if rotate 360 degree about y-axis, you will obtain a ball like this. So the basic shape like sphere, like cylinder, we can use the basic formula to find the volume. However, if you have the ball like this, so it's impossible you find the volume by using this. And this one you cannot say is hemisphere, not necessary is hemisphere. So that's why we introduce integration to help you to find the volume for the solid generated. So let's look at example 21. So find the generated volume in terms of pi when a region bounded by the curve and the line x equals to 0, x equals to 2 is revolved 360 degree about the x-axis. So this one have a few information. Number one, you must know where is the region that you have. So the region that you have, we see bounded by the curve. So this is the curve. X equals 0, x equals 2. So x equals 0, x equals to 2. And also the x-axis. So this shape revolve 360 degree about x-axis. So try to imagine you will obtain the something like this, something like loudspeaker. Okay, so how we're going to, if you cannot imagine the shape, actually it doesn't matter. So the most important is you will know how to build the formula out. So I'm going to teach you how to build the formula out. So the volume formula will be equals to pi integrate. Okay, volume, very good. They will tell you which axis to use straight away. Different with the area. If area, they won't tell you which axis to use. If volume, they definitely will tell you. Okay, why? The reason why, later I will share with you. So this one, you see, about x-axis, meaning that integrate dx. Pi always have here. So integrate dx from where to where? Then you need to see x-axis from 0 until 2. So 0 until 2. If here is x, then you need to substitute y square. If here is y, then you need to substitute x square. So this one y square, y is this, right? So y square meaning that 2x square plus 3 whole thing power 2. So how to integrate this? So just expand, because of power 2, you expand like usual using the SMS method. Square this part, getting 4x power 4. And then 2x squared times 3 times 2, you're getting 12x squared plus 9. After that, you do integration like usual. 4 copy, x copy, power plus 1, divide the power, and then plus 12 copy, x copy, power plus 1 become 3, divide 3, plus 9, integrate 9, getting 9x, and then from 0 to 2. Next step, just substitute when x equals to 2 minus when x equals to 0, and then key in calculator, getting this answer. So this volume is the volume for this solid, okay? So now look at if rotate with y-axis. So how to build the formula? So imagine this shaded region, if rotate with y-axis, you will obtain something like a ball like this, the blue color. So how to build the formula for this? Similar, volume equals to pi integrate, because the question says with rotate y-axis. So dy here, pi here, integrate from a to b. So a to b. If here is y, then you need to substitute x squared. So memorize the formula. So look at this question. Find the generated volume in terms of pi when the shaded region, for this one, in the diagram is rotate 360 degree about y-axis. So how are you going to form the volume formula? Volume equals to pi integrate rotate y-axis. So here is dy. Y-axis from where to where? From 1 to 4. 1 to 4. Here is y. Then you need to substitute x squared. So how to obtain x squared? Obtain from the diagram there. You have the equation already. X squared will be equals to this one. Y and x exchange position. So you have x equals to 6 over y. So x squared is 6 power 2. So 36. Y power 2. So meaning that 36 y power negative 2. Then when you have this, you can do the integration like usual. So number copy, y copy, power plus 1, negative 2 plus 1 become negative 1, divide negative 1. So integrate like usual, and then substitute when when y equals to 4 minus when y equals to 1. Then keep calculator. So this is the answer. So look at example 23. So example 23 involving the volume generated for the region bounded by the curve and also the straight line. For these cases, you need to minus just like the area formula. So can you imagine this? What happened in this question? So let's look at the question. In the diagram on the right, so the curve, so this curve intersect the straight line at O and A. So we have two intersection point. One is 0, 0. Another one is this point. So how to get this point? Because this is intersection point, so you just solve it simultaneously. So solve it simultaneously like this. Cross multiply, bring it to the left hand side. So quadratic equation, factorize it, getting 0 and 4. So when x equals to 4, so this point you know is 4. Okay, after substitute, then you know this point actually is 4, 4. Substitute when x equals to y. So 4, x is 4, meaning that y also 4. Already know the coordinate A here. So question B. Find the generated volume in terms of pi when the shaded region is revolved fully about x-axis. Meaning that later on your volume will be integrate pi integrate with respect to x-axis. So integrate dx from 0 to 4. 0 to 4. So this time you need to be careful. You need to try to imagine like the area like the one area that I teach you. When you involve straight line and curve, what you need to do? You need to use, if the area is flying in the sky, you need to use above minus below, right? So for these cases, for volume also the same. You need to use, because I said x-axis, right? Meaning the x-axis is the floor. So the one above is the straight line, meaning that you need to integrate straight line volume minus the curve volume. Straight line volume minus the curve volume. If you cannot imagine, I'll draw out for you at here. You try to imagine. So what happened if I integrate the straight line? If I integrate this straight line with respect to what x-axis, can you imagine I can get a cone? I can get a cone if I integrate the straight line. And then if I integrate the curve, if I integrate this curve, I can get the shape like this. So meaning that white color, this one, straight line minus this, then I can get the what we call this shape. Can you imagine the shape? The one something like a ring. Don't know how to explain the shape. Okay, something like because the whole thing is cone. So you try to imagine the whole thing is cone. You just cancel this part. The something like the loudspeaker. Cancel this part and then remaining the shaded part. Okay, so how to find the volume for this one? Do the same thing using above minus below. So in these cases, remember the formula that you need to have is straight line minus curve. So do the same thing. So volume equals to pi integrate from 0 to 4 dx. So for straight line, equation is, if here is x, need to substitute y square, right? When you substitute y square meaning that y square is x. Then need to minus pi integrate the curve. So integrate the curve for dx. Also from 0 to 4. Here is x, so substitute y square. So y square power 2, meaning that 1 over 16 x power 4. Then you continue, do the integration like usual. So for these cases, they do it separately. So let's see. Here is x power 2. So x power 2 become plus 1, power plus 1 divide the power. Then substitute, get the answer. Volume for number 1. Just now why I put x? I forget x square. Because it's, you need to substitute y square, right? So y square, just now I write y square. So substitute x square here. This one is square. I write wrongly just now. So this part, see, the cone already get it using integration. If you want to find the volume for cone using the formula, actually also can. So volume number 2 is curve. This one is integrate for straight line. This one integrate for curve. So integrate pi 0 to 4, 1 over 4, become 1 over 16 actually, and here exactly the same. So integrate like usual, number copy, x copy, power plus 1, divide the power. Then you just key in calculator, 1 over 16 divide 5. Then you substitute and get the answer. So this one is the one straight line, cot minus this one, then you get the answer that you want. So far, okay? So serve exercises 3.7. Please try to do it. You have 4 questions there.